Oh, greetings, Gen Chem students. Welcome back. This is a video demonstration of Part D of the online gas lab that you're doing this week. And this section D I'm calling Experiencing Gas Density. And let's look at this piece of paper here. I have some notes. Let's say we have 3 balloons filled with different kinds of gases. Here we have helium, air, and sulfur hexafluoride. Now notice that the helium balloon has a volume of 1 liter, but 1 liter. So does the air, and so does the sulfur hexafluoride balloon. And they each have the same temperature. Each are at 20 degrees C, and they each have the same gas pressure, 1 atmosphere. Now, Avogadro's law, and actually the ideal gas law as well, the ideal gas equation, shows that different gases of equal volumes at the same temperature and pressure will have the same number of moles, the same number of gas particles. And you can see that from the ideal gas law, where N, the number of gas particles, is equal to PV over RT. And we know each has the same pressure, each have the same volume, each have the same temperature. And you know all gases share the same value for the universal gas constant. So each of these gases have exactly the same number of particles, but they have drastically different densities. And that is because the particles have very different masses. The sulfur hexafluoride molecules are much more massive than air molecules, and air is composed of primarily oxygen and nitrogen. And air molecules, nitrogen and oxygen, are much more massive than helium atoms. So these have very different densities. And it turns out that the density of the sulfur hexafluoride is much greater than air, and the density of air is much greater than helium, simply because their particles are more massive. SF6 is more massive than air, and air is more massive. Its particles are more massive than helium. And these drastically different densities produce really interesting and different properties, different behaviors. Well, by the way, before we look at those behaviors, remember this equation. This is the density equation. It's actually a form of the ideal gas law. The density of a gas is equal to P, the pressure, times the molar mass over RT. But now let's look at these different properties, behaviors that are created by the different densities of gases. Okay. And here we have a balloon filled with air and a balloon filled with helium. They're approximately the same volume, same temperature, same pressure. So they have the same number of particles, but their density is much greater. I'm going to release both of them at the same time, and we'll see the density difference exposed. Right? The helium balloon takes off. It's less dense than the air, and it's buoyant, and it shoots up. Now let's look at sulfur hexafluoride. This is sulfur hexafluoride and an air balloon, again about the same size, same volume, same temperature, same pressure, so they have the same number of particles approximately, but this balloon is much heavier because the particles, even though they're about the same number of particles, these particles are much heavier. Now I'm going to release both at the same time, and what do we see? See, the sulfur hexafluoride is much more dense, right? And so that's one experience. Now another is the, should have had my scissors ready, the voice. If your voice box is submerged in air when you're speaking, and your vocal cords are vibrating in that, in air, the density of air. So if you were to breathe in helium and speak with helium gas in your voice box, then the vocal cords are going to be vibrating in a much less dense, can't get this guy going, there we go, a much less dense medium, and therefore they're going to be able to vibrate more freely against less resistance. It's like the difference between running in water and running through air. And this would be like, the vocal cords are going to be much more free and able to vibrate more quickly and helium. So let's see that.
And there we go. Well, I didn't get as deep. You can tell my voice is higher. I'll try to get a bigger gulp this next time. It's hard to get helium in your voice box because as soon as you release the balloon or open the balloon, the gases are taking off. But let's try it again. There we go. Well, get a little bit higher, but I still didn't get a good breath, and it would really take it down. But you can hear the voice is higher. So now, with that little experience behind you, we see that as the gas density decreases, your vocal cords vibrate faster, the gases move more quickly, and the voice has a higher pitch. So what would you predict would happen if we breathe in a little bit of sulfur hexafluoride? Get that into the voice box. Now the vocal cords would be saturated or submersed in this very dense gas, and we would expect, and the molecules are going to be moving less rapidly. They're going to be vocal cords vibrating against a more viscous medium, and let's see what happens. Got to get all the helium out. Okay.
And there we go, yes. And now, this is my voice with the sulfur hexafluoride. It's quite a bit lower, isn't it? And that's because, again, of the factors we talked about, the vocal cords vibrating in a more viscous medium, and these gas particles move much more slowly, and the result is a much lower sound voice. Now, after this demonstration is over, I'm going to have to do a headstand to make sure I get all that sulfur hexafluoride out of my lungs. But sulfur hexafluoride is not toxic. It's inert like helium, so it won't harm me, but you don't want to displace oxygen in your lungs either. So, that's it.